Hi everyone, in this video we're going to continue our study of section 1.6, multiplying and dividing complex numbers. So my first example is multiply these two. So we have a real number 2 times a complex number. So just as we've done before and as we did before, think of with addition and subtraction, I want you to think of the I as if it was an X, what would you do? If it was a Y, if it was just a variable, what would you do? It's just the difference here is that I is actually a number. Remember, I is equal to the square root of -1. So we're going to use the distributive property and distribute the 2 in. So this is going to become 2 times 3, which is 6, minus 2 times 4, which is 8i. And that will be it. We have a complex number here. Now for the second one, we have a binomial times a binomial. So we have to use a little bit more of the distributive property. Here it was a monomial times a binomial. So we only had to distribute the 2. So here, let's do our distributive property. You could also use FOIL. I tend to use the box method for multiplying binomials or any polynomial really. And so what I do is create the box, and then my first binomial 5 minus 3i, so I'm going to do 5 and negative 3i, and then 2 minus i is the other one, so 2 minus i. And then we multiply. It's kind of like finding the area of each little box here. So the area of this first box is 5 times 2, which is 10, and then 5 times negative I would be negative 5i. Negative 3i times 2 is negative 6i, and negative 3i times a negative I, negative times a negative becomes positive. 3 times, there's an invisible 1 there. So negative 3 times negative 1 is positive 3, and then I times I is I squared. And the reason I like the box method is because oftentimes the common terms, the like terms, are going to line up along the diagonal. So my answer here is going to be 10, the 10 here. And then combine these are like terms, so minus 6 minus 5 is negative 11i, and then I have plus 3i squared. But remember, I is equal to -1, I squared is equal to, I is equal to the square root of -1, and this is equal to, I squared is equal to just -1. So I'm going to have 3 times -1 here. Instead of I squared, replace I squared with -1. And so, what does this become? This is 10 minus 11i minus 3, which is 7 minus 11i. So that will be the product of those two complex numbers. So notice I still have a real part and an imaginary part. For the third one, multiply 4 minus 5i squared. So here, be careful not just to square the 4 and the 5i. Don't say 16 plus 25i squared. We have a middle term here, so this is the quantity squared. So that means 4 minus 5i times itself, 4 minus 5i. So you can use the box method above, or we can use, in this case, I'm going to do a different example with the FOIL method. So the FOIL method is you do the first. So I'm going to get 4 times 4 is 16. Then you do, so FOIL. Right, so the outer, so 4 times negative 5i, so negative 20i. The inner, negative 5i times 4, so minus 20i again. And the last, negative 5i times negative 5i. Negative 5 times negative 5 is positive 25. And then we have I squared. Now remember that I squared is equal to the real number -1. So we can replace that. So I really have 16 minus 40i, and then 25 times a -1 is -25. And so 16 minus 25 is -9 minus 40i. So this will be the answer for this. So be careful about not forgetting that middle term. Don't just square each of the terms, right? You have to the quantity square means you have to separate it in FOIL, or if you are a fan of the box method, as I am, do the box method. So let's try another one. Alright, so for the next one, I want to multiply 3 plus 2i and 3 minus 2i. And these, notice that the real part is the same, and the imaginary part is the same coefficient in the I, except that they're opposite signs. So we say that those are conjugates. So 3 minus 2i is the conjugate of 3 plus 2i, and vice versa. I can say 3 plus 2i is the conjugate of 3 minus 2i, and so on. So you may get some answers, some questions. What is the conjugate of something? So if I ask you what is the conjugate of, say, 1 minus 7i, the conjugate of that then will be 1 plus 7i. What is the conjugate of negative 2 minus I? The conjugate of this, but let me say negative 2 plus I. The conjugate of this will be negative 2 minus I. You only change the sign of the imaginary part, not of the real part, so that will stay minus 2. Okay, so how do we multiply these guys? So I'm going to go back to my box method just because I prefer it. But if you prefer FOIL, then just go ahead and stick with what you like. So I'm going to have 3 plus 2i and 3 minus 2i. And let's multiply. So 3 times 3 is 9. 3 times negative 2i is minus 6i. 2i times 3, there are no negatives here, so this is positive 6i. And then 2i times negative 2i, so I have a positive and a negative. So positive 2 times a negative 2 is negative 4. I times I is I squared. And now we can combine like terms. So my like terms are on the diagonal there. And notice what happens to this 6i minus 6i. Those cancel out. So if I write them out, I'm going to have 9 minus 6i plus 6i minus 4i squared. Remember, I squared is negative 1. So the middle terms here cancel. So I'm left with 9 minus minus is positive. So 9 plus 4, which is 13. And so multiplying conjugate complex numbers gives us a real number. So that's an important thing to know, especially in division. So let's move on to division. Well, actually, let me do another example of this. So let's try this part B over here. So what if I wanted to multiply these conjugates? Just to verify that we will get a real number. So if I multiply negative 2 plus I times negative 2 minus I, what are we going to get? So we're going to do negative 2 times minus 2, so that's a positive 4. And then negative 2 times a negative I, that would be what? Negative times a negative becomes positive, so plus 2i, and then I times negative 2 minus 2i. And so that's why they end up canceling, because they're conjugates. One is going to be positive and the other is going to be negative for that middle term. And then positive I times a minus I, positive times a negative gives me negative. I times I is I squared. So the reason that these always, when you multiply two conjugate numbers, you're going to get a real number is because the middle terms, that the ones that have the I, end up canceling, and the remaining term that has the I is an actual I squared. And remember, I squared is equal to negative 1. So you end up with no imaginary numbers. So 4 minus a negative 1. Write the minus because that's what was there, and the negative 1 because that's what I squared equals. So we get 4 plus 1, which is 5. All right, so let's talk about division. Okay, so for division, we'll start a little bit small. So say I want to divide 2, the real number 2 divided by the complex number I, the imaginary number. So this, thinking back to what I means, I is the square root of -1. So you have a radical in the denominator, so normally we want to rationalize the denominator. So that means, back to the study from previous sections, to rationalize the denominator, we want to multiply by the radical to get rid of it. Right, so then I'm going to have 2 times the square root of -1 times the square root of -1 times the square root of -1 is the square root of -1 squared, which then will just give me -1. So this will be -2 times the square root of -1, but the square root of -1, we know it's I. So I get -2I. Of course, this is the long way of doing it using the square root. Leaving things in rational form, in imaginary form, I would multiply, instead of changing the I to the square root of -1, I just did it as the square root of -1 to illustrate why we do this step. So here I multiply both top and bottom by I, right? I over I is 1, square root of -1 and square root of -1 is 1. I have not changed the value of this when I multiply by a funny looking 1. So this allows me to then say 2I over I squared, which is 2I over -1, so that's -2I. So I get there much faster. But I just did this to illustrate why do we multiply by the I, is because it's technically a square root. And whenever you have a square root in the denominator, we want to rationalize it, we want to get rid of it. So let's try another example. So say we want to divide 6I over 3 plus 2I. So here I want to get rid of, remember the I is the square root of -1, so I want to get rid of that. So that means we're going to multiply by the conjugate. So here I'm going to multiply it with 3 minus 2I and 3 minus 2I, right? That's a funny looking one. 3 minus 2I divided by itself is equal to 1. So we have not changed the value of this expression. I'm just multiplying by 1, so I'm not changing it. So I'm going to have 6I times 3 minus 2I on the top, and on the bottom, these are conjugates, which hopefully they look familiar. 3 plus 2I and 3 minus 2I were the ones that we did up here. So we don't have to redo this work. 3 plus 2I, 3 minus 2I, we got a value of 13 when we did it above. So I know from a previous work that this is going to be 13. So I just need to multiply the 6I, and so I'm going to have 6 times 3 is 18I minus 6 times 2 is 12. I times I is I squared over 13. So I get 18I minus, remember, I squared is -1, so it's really -2 times a -1, so plus 12 over 13. And normally we write the real part first. So this will be 12 plus 18I divided by 13. In the homework, you may be asked to write the real part separate from the imaginary part, which just means splitting up the fraction. So the 12 over 13, that's the real part, plus 18 over 13I, and that's the imaginary part. Okay, we'll do one more, and then that'll be it. So say I want to divide 5 minus I divided by 1 plus 3I. So same thing, I is the square root of -1, so we want to think about multiplying by the conjugate. We want to make this a real number. So I'm going to have 1 minus 3I times 1 minus 3I. And now there's a binomial there. Okay, so this one requires us to do a little more work because we need to multiply the whole denominator and the whole numerator. So what we're going to have is in the numerator 5 minus I times 1 minus 3I divided by 1 plus 3I times 1 minus 3I. Right? And here we should get a real number. No i's. So let's start with the numerator. Multiply it out. You can either use FOIL or the box method. So I'm going to have 5 minus I and 1 minus 3I, and then just multiply. 5 times 1 is 5. 5 times negative 3I is negative 15I. Negative I times 1 is negative I, and negative 1 times a negative 3I. So negative times a negative is positive, so I'm going to have 3I squared. That I squared is negative 1. So when I put it all together, we're going to have 5, this 5, and then combine those like terms. Minus 15 minus 1 is negative 16I, and then 3I squared, so plus 3 times negative 1. So that becomes a negative 3. So I have 5 minus 3, which is 2 minus 16I. So that's the numerator. Now let's go to the denominator. And you can do shortcuts in the denominator if you know, okay, those are conjugates, so that means no middle term. But I'm just going to do it out just so we get used to seeing that, in fact, the middle term does cancel out. So what do I have? 1, 3i, and 1 minus 3i. So 1 times 1 is 1, make it negative 3i, positive 3i, and 3i times a negative 3. So 3 times negative 3 is negative 9. I times I is I squared. So I get 1. And notice the middle terms, right? Those cancel out. 3i minus 3i is 0, so I don't have it. Minus 9i squared. I squared is negative 1. So I get 1 plus 9, which is 10. So this is the denominator, and this was the numerator. So let's put them back together. So I'm going to have 5 minus I over 1 plus 3i. This is my original problem. After the work that we did, we end up with the numerator 2 minus 16i over 10. And notice that everything here is even, so I can factor out 2 from the numerator. So I'm going to have 2 times 1 minus 8i over 10. And the reason I do that is because I notice that everything is even, so I can say 2 goes into 10 5 times. So my final answer will be 1 minus 8i over 5. And again, you can think about splitting up the real and the imaginary part. So this will be 1/5 minus 8/5 I. So 1/5 is the real part, negative 8/5 I is the imaginary part. I hope that helps. Some of the things to be careful are to not just to cancel things off without taking it out completely, right? So don't just do the 2 and the 10. You can't reduce over a negative, over addition or subtraction. You have to do the whole thing. Yeah, email me if you have any questions.